simple mole-to-mole equation. So our first problem would be, what is the greatest amount of Sn, which is in the element it is named in, with a coefficient of 3 of H, which is hydrogen, in moles that can be made with 6.8 moles of Sn and 4.6 moles of H. The question is, which is the limiting reactant, which is reactant is in excess, and how many moles of it are left over. So we have here our given from the number 1 problem. Our given is Sn is equal to 6.8 moles, H is equal to 4.6 moles, and to use all Sn, how many moles of H do we need? We have here 6.8 moles of Sn. We're gonna multiply it by the coefficient of H, which is hydrogen, over the 1 moles of Sn. So we're gonna apply the cancellation property, and that would be 6.8 multiplied by 3 moles of hydrogen over 1. So the result would be 20.4 moles of H. And for the hydrogen, to use all hydrogen, rather, how many moles of Sn do we need? We have here 4.6 moles of hydrogen multiplied by 1 moles of Sn over 3 moles of H. It is the same process of the problem number 1. We're gonna cancel down the word moles of hydrogen. So it would be 4.6 multiplied by 1 moles of Sn over 3. And that would result to 1.53 moles of Sn. So our excess reactant is Sn, which is in element name is tin, and our limiting reactant is H, which is hydrogen. So we're gonna go solve for the greatest amount of product. We have here 4.6 moles of H multiplied by 1 moles of Sn over 3 moles of H. We're gonna go to cancellation property, and it would be 4.6 multiplied by 1 moles of Sn over 3. That would result to 1.53 moles of SnH with a coefficient of 3. For the excess reactant, we have 6.8 moles of Sn subtract by the product. It would be 1.53 moles of Sn, and the result would be 5.27 moles of Sn, or in element name tin. So we have here our second problem, which question, what is the greatest amount of Ag2Na in moles that can be made with 3.6 moles of Ag, which is silver, and 9.2 moles of Na2, which is the limiting reactant, which is the reactant in excess, and how many moles of it are left over. So this is our unbalanced equation. This is the reactant side, and this is the product side. And our balance equation is, this is our reactant side and this is our product side. So both are balanced. And for the solution, my co-member will discuss it to
you. Here's the solution of number 2. So the given here is Ag silver, which is 3.6 mole, Na2, which is sodium, 9.2 mole. So to solve this, we need to put this here, 3.6 mole Ag multiplied by 1 mole Na2 divided by 2 mole Ag. So the calculation of this is equals 1.8 mole Na2. So to get this, we need to crush this 2 out. This 3.6 mole Ag and 2 mole Ag. So to get this, excess reactant 9.2 mole Na2 multiplied by 2 mole Ag divided by 1 mole Na2. So the calculation of this is 12.4 mole Ag. So to get this, we need to crush this 2 out also. And to solve the greatest amount of product, Ag2Na is 3.6 Ag multiplied by 2 mole Ag2Na divided by 2 mole Ag. So the calculation of this is 3.2 mole Ag2Na. So this is the maximum product obtained after Ag, which is silver run out. So to get the excess reactant, 9.2 mole Na2 minus 1.8 mole Na2 equals 7.4 mole Na2. So this is the leftover of excess reactant has. So here's the problem of number 3. What is the greatest amount of Na2PO, Na2, which is sodium, and PO, which is polonium, in moles, that can be made with 12.2 moles PO and 18.4 moles of Na3, which is the limiting reactant, and which reactant doesn't exist, and how many moles of it are left over. So this is the formula of how to solve the solution. Unbalanced equation can PO, which is polonium, plus Na3, which is sodium, and Na2PO. And the balanced equation also is 3PO plus 2Na3 and 3Na2PO. So here's the solution of number 3. So the given here is PO, which is polonium, and 12.2 mole, Na3, which is sodium, 18.4 mole. So polonium here is, we need to put it in here, 12.2 mole PO multiplied by 2 mole Na3 divided by 3 mole PO. So the calculation of this is equals 8.13 mole Na3. And the excess reactant here is 18.4 mole Na3 multiplied by 3 mole PO divided by 2 mole Na3. So the calculation of this is here equals 27.6 mole PO. So to solve this, we need to crush this 2 out. This 12.2 mole and 3 mole PO. So to solve the greatest amount of product, Na2PO, 12.2 mole PO multiplied by 3 mole Na2 divided by 3 mole PO. So the calculation of this is 12.2 mole Na2PO. So this is the maximum product obtained after PO, which is polonium right now. So to get the excess reactant, 18.4 mole Na3 minus 8.13 mole Na3 equals 10.27 mole Na3. So this is the excess reactant left over.
So starting, so here's our problem. So our given, so where we get this, we get the given from the problem. So 86 grams, there is 72 and 66. So now just copy this to be organized. And first, to be organized, we need to find first the molar mass of each chemical symbol, because this is gonna be useful later on. So now, how to find molar mass? To find molar mass, you need to use periodic table. So in the periodic table, to find molar mass, K has a molar mass of 39.10 and it has 2, so it means you need to times it into 2. O has 16 and there's a 3, it means again you need to times it into 3, and H has 1 molar mass and you need to times it to 3, and the total of 129.2 grams. Now same as there, AI has 26.982 molar mass and N has 14.006, but it has a 2 here, so it means you need to times it into 2. Now the total of 54.994 grams. Now same as here, you need to find molar mass. AI has 26.982. There's a 2, so it means you need to times it into 2. O has 16, H has 1, and you need to times it into 2 of each symbol. The total of 87.964 grams. Now, to find limiting reactant, since we're given grams, we need to convert it into moles first. So first we need to be organized, so we need to solve the reactant side. The reactant side is here, so which belong of K2OH3 and AIN2, and this we call here is our product side. Sorry. Now first we need to solve this first, so just copy 86 K2OH3 times where we get this. So 129.29, we get this from the molar mass of K2OH3 there. So just put in there and just put 1 because it's constant and understandable. Just put 1 to convert into mole and cancel it out, and 86 times 1 divided by 129.2, it has 0.6656 mole of K2OH3. Sorry. Now the second is the 72G AIN2. You need to times it again. We get this from the molar mass of AIN2. Here it is 54.994, and just put 1 mole here again because it's understandable to convert it into a mole, and the total of 1.3092 mole of AIN2, and this we called our available. So now we can now solve mole to mole to find the required of each symbol. So 0.6656, we solve this from this. To be organized, we solve this first, so times we get the 1 mole of K2OH3 from there. We base it from the molar the chemical balance equation. So it has this we call the diatom coefficient, and that's we call also the mole. We base it from the coefficient from the balance equation. So the mole of K2OH3 has 1 mole. So the AIN2 has 2 mole. So times 1.3312 mole. And that's the answer. Okay, so second is here 1.392. again, to times it mole to mole, we find it from the balance equation. So AIN2 has 2 mole there, as you can see. There's a 2, so just copy 2. 1 mole of K2OH3 there has 1 mole, and just put, so 1.392 times 1 and 2 equals of 0.65. Now, how to find limiting reactant and excess reactant? We base from the answer of our required mole from the available mole of each symbol. So the available of mole of K2OH3 has 0.6656, but here in required of K2OH3 has 0.6546, so it's exceed. So it means it's our excess reactant. Now, it's understandable that our limiting reactant is AI and 2. Why? Because from our required, it has 1.3312, but the available here is only 1.3092. So it's lack or not enough of mole. So it's our limiting reactant. Now, how to solve the leftover? Since our excess reactant is K2OH3, we need to focus from the excess reactant, which is our K2OH3. K2OH3 of available and the required. So first, our available of K2OH3 has 0.6656. So there, just put and minus the required of K2OH3. So it has 0.6546. So there, and 0.6656 minus 0.6546 is equal of 0.011 mole K2OH3, and that's we call our leftover. Now, how to solve? We're going now to solve our theoretical yield. Solve theoretical yield. Now, where we get this? So theoretical yield is focusing on our limiting reactant. So our limiting reactant available is, so if our limiting reactant is AIN2 and our available is 1.3092 mole of AIN2, and we get this from this, and just put, so you need times it and put mole of AIN2, so to cancel it out. So we get this again from the balance equation there. So AIN2 has 2 mole, as you can see there. So we get this again from and it's our product side. So that's our product side here, focusing on here. So AI2OH2 has 1 here, so just put 1 here, and equal the total of 0.646 mole of AI2OH2, and that's we called our greatest amount, or that's our theoretical yield. Now, how to solve percent yield? So we get the theoretical, which is there. Now we have no actual, so we need to solve actual. So how to solve actual? So actual, our actual is given from AI2OH2, which is there. It has 66 grams, so just put in there times. Now where we get this? We get this from the molar mass of AI2OH2. So before we start, let me read the problem first. So 124 gram of SnH2 reacts with 114 grams of PO. After the chemical reaction, 86 gram SN2P were collected. What is limiting reactant, excess reactant, and the leftover? Calculate the theoretical and percent yield of SN2P. Now, we're given a balanced chemical equation, so we can start now. To be organized, we can start to put there the given. So where we get this? We get this from the problem. So SnH2 124 grams, as you can see there, and PO has 114 grams, as you can see for there, and the SN2P 86 grams are there. Now after that, we must solve first the molar mass of each of them, because because this is gonna be a useful later on. So molar mass of Sn has 118. By the way, we can use to find molar mass is we can use a periodic table. You can see out there. So now again, Sn has 118.71 plus H has 1 molar mass. There's a 2, so it means it times 2. It equals 120.71 grams. P has 30.97. O has 16 molar mass. Overall has 46.97 grams. Sn2P, Sn has 118.7. There's a 2, it means times 2. P has 30.97. The total of 268.39 grams. Now we can start now to find limiting and excess reactant. So limiting and excess reactant is focusing on reactant side. So reactant side is this. This we called our reactant side. So it means we must focus on there. So we focus on this too. So first, just copy, put 124 grams, we get there from this, times, by the way, we must calculate first to convert them to grams to moles. So again, just copy, times, we get this from the molar mass of SnH2, which is there. Yes, you can see, yes. And just put 1 mole. Again, it's a constant. It's understandable to convert it into a mole. So cancel out. 124 times 1 divided by 120.71 grams is equal of 1.03 mole SnH2. Now solving for PO. So again, PO 114 grams, we get this from there. Again, times, we get this from the molar mass of PO, which is there, 46.97 grams. Again, just put 1 above to convert it into mole. Cancel out. 114 times 1 divided by 46.97 is equal of 2.43 mole PO. Now we can solve now the moles to moles of each symbol. Now focus on there, okay? So first, 1.03 mole SnH2, just put in there, times 2 mole SnH2. Now question, where we get this? We get this again from the balanced chemical equation. The mole of SnH2 has 2. As you can see, that's we call our mole or our coefficient. And above has mole of PO has 1. We get this from, again, the mole, the chemical equation. There's a 1 in here, so 1. So 1.03 times 1 divided by 2 is equal of 0.52 mole PO. Now second one is PO. Again, just put times, same as here, mole of PO. Again, we get this from the balanced chemical equation. PO has a 1 mole. Sorry. SNH2 has 2 mole. Just put in there. 2.43 times 2 divided by 1 is equal of 4.86 mole SNH2. Now we can identify which are the limiting reactant and the excess reactant. Now how to identify? Now this we called our available, and this we called the required. Since the required of PO has 0.52 and the available of PO has 2.43 mole, so it means PO, because it has only available has 2.43 but the required is 0.52, so it exceed, so it means excess reactant is PO, as you can see. Now limiting reactant, again same as finding excess reactant. 4.86 mole is the required. 1.03 mole of SNH2 are the available. It's like not enough, as you can see, because the available has only 1.03 and the required is 4.86, so it means limiting reactant is SNH2. Now we can find now the leftover. So leftover is focusing on excess reactant. Since our excess reactant is PO, we need to focus the excess reactant, the available of excess reactant, and the required of excess reactant. Our available has 2.43. Just put, as you can see, and we put this again, as I said earlier, the required has 0.52, so just put and minus, and a total of 1.91 mole PO, and that's our leftover. Now we can now solve theoretical yield. Now theoretical yield is focusing on available of limiting reactant. Our limiting reactant is NH2 and our available was 1.03. So just again, as you can see, just put times, again we get this from the balanced chemical equation. As you can see, SNH2 has 2 mole and a mole of SN2P. By the way, SN2P, we get this from the product side. That's we call our product side. And for the product side of SN2P has 1 mole. And just multiply 1.03 times 1 divided by 2 is equal of 0.52. And that's we called our greatest amount. Now, to solve percent yield, we focus on the formula. Since we get the answer of theoretical yield, as you can see there, we find the actual first. Now, how to solve actual? This focusing on the product side of which is the SN2P. Now, where we get this? We get this from the given. There it is, as you can see, 86. Now times, we get this from molar mass of SN2P, which is there, as you can see. Okay. Now again, to convert it into mole, just put 1, and 86 times 1 divided by 268.39 is 0.3204 mole of SN2P. Now we can solve now the percent yield. Just put the answer 0.3204 divided by 0.515 is equal of 62.22%, and that's our percent yield. Now how to solve the error, the percent of error? Just minus it into 100% minus the answer of the percent yield, which is 62.22, is equal of 37.78, and that's the total of percent yield. I mean the percent error.
So here is our problem. So this is our given, which we get this from here. So energy C2 from here, O has NH from here, and energy of 4 from here. So we need to organize this. So in able to organize this, we need to find their molar masses in periodic table. So Mg has a 24.31 and C has a 12.01. Then because it has 2 beside it, it means we need to multiply this by 2. So the total molar mass of this is 48.33 G. Then the same as here, we need to find the molar mass and just simply add and the total of it. O has a 15, and as NH has a 118.71, and H has a 1 molar mass. So it has 3 beside it, so which means we need to multiply this by 3. So the total mass of this is 374.13 G. And the last one is Mg has 24.31 molar mass, and 0 has 16. Then it has 4 beside it, so which means we need to multiply this by 4. So the total molar mass of this chemical symbol is 88.31 G. And your excess reactant, which means we must focus on this reactant side. We focus on these 2 symbols, chemical symbols. So first, we copy this 204.50 G times 1 mole. By the way, we need to calculate this first again to convert it from grams to mole. So 1 mole, then 48.33 G, which we get this from here, from the molar mass of MgC2. So cancel out. 204.50 G times 1 divided by 48.33 G is equals to 4.23 mole MgC2. So this is the total of the answer. So second, the 96 G. So we get this from here and copy this. Let's copy 96 G times 1 mole. Again, it's constant, so it is understandable to convert it into mole. So then 374.13, which we get this from here, from the molar mass of SNH3. So cancel out. 96 G times 1 mole divided by 374.13 is equals to 0.26 mole SNH3. So this is the total. Then second, we need to focus this side. So first, 4.23. So we just copy this. 4.23 mole MgC2 times 4 mole. Again, I times 2 mole MgC2. Question: where did we get this? 2 mole. We get this from the from the chemical equation, which is it has 2 beside this, so that's why we just copy this 2 mole MgC2. Then above, it is also it has also 4 beside the S and Hg, which we copy this, so that's why it is 4 mole OS and H3. So cancel out 4.23 mole times 4 mole divided by 2 mole is equals to 8.46 mole OS and H3. So the same as here, 0.26, we just copy this 0.26 mole times 2 mole, which we get this from the above, what we call this chemical, it is from above. Then 4 mole, which we get this from here, then cancel out 0.26 mole times 2 mole MgC2 divided by 4 mole is equals to 0.13 mole MgC2. So this is the total.
To continue how to identify limiting reactant and excess reactant. Now first, this we called our kundi ay atong available, and this we called our required mole. Now we can identify now the limiting reactant and excess reactant. Now how? First, let's OSNH3 has required of 8.46, but the available mole of SNH3 has 0.26. So it means it is not enough. So therefore our limiting reactant is OSNH3. Now our excess reactant is MgC2. Why? Because the required mole of MgC2 is 0.13. However, the available mole of MgC2 is 4.23, so it exceeds. So it means excess reactant is MgC2. Now how to solve leftover? As you can see, leftover. Now, since our excess reactant is MgC2, we focusing on the available and the required mole of MgC2. As you can see, 4.23 is the available, and we minus it into a required mole of MgC2, which is 0.13, as you can see, and the total of 4.1 mole MgC2, and that's we called our leftover. Now, how to solve theoretical yield? We get this from the available mole of SNH3, which is this, times, now 4 mole, we get this from the balanced equation, which is as SNH2 has a mole of 4. Just see it from the previous video, as you can see in the Manila paper. And mole of MgO4, which is the product side, our product has 1 mole. Again, just see it from the previous video, which is the Manila paper. And the total of 0.065 mole of MgO4. By the way, I forgot to cancel it out, sorry. Again, the total of 0.065 mole of MgO4. Now, how to solve percent yield? This is the formula. As you can see, we find the answer of theoretical yield, which is this. So we have now a theoretical. Now we have no actual. So how to solve actual? Now solving actual 125G MgO4, we get this from the given. Just see it from the previous again in the Manila paper times 80. We get this DI from the molar mass of MgO4. Just see it again from the previous, which is the Manila paper, and again just put above a 1 mole to convert it into a mole. So a total of 1.42 mole MgO4 or 1.4154 mole MgO4. Now we get the answer, so we can now solve. Just put in there. So 1.415 mole MgO4 divided by 0.065 mole MgO4, we get 21.85%. Now how to solve? Now to solve error, just minus it into 100. 100 minus 21.85, we get a 75.15, and that's our percent error. That's all. I hope you learned something.